Bismillahirrahmanirrahim. We come to the third part of the inverse functions. In the last two parts, we discussed the definition of the function, and we said that the function is a set of ordered pair where there is no repetition in the x-coordinate, or each element in the domain has only one image in the range of the function. And we said that we have some functions that are, we call it one-to-one, and some others are not one-to-one. And we said that one-to-one function means that each element in the range of the function has only one pre-image. So in the definition of the function, we look at the domain. If each element in the domain has only one image in the range, we call this is a function. If each element in the range has only one pre-image in the domain, we call it one-to-one function. Then we discussed the composition of the inverse function property, and we said that two functions are said to be inverses if, for example, f and g. If f composite g will give me x and g composite f is equal to x. In this part, we are going to discuss how to find an inverse for a given function. Let's start with the example. Let's say we need to find f inverse. This notation f to the power minus 1 means the inverse function or the f inverse. Number one, so with that we have this function f of x equal to 2x minus 4. And we need to find the inverse for this function. To find the inverse of a given function, we have 3 steps. Step number 1. Replace f of x by y. Let f of x equal to y. I'm going to take this f of x and replace it by y equal to 2x minus 4. So step number 1, replace f of x by the variable y. Step number 2, replace y by x and x by y. You can say interchange between y and x. Let x equal to y and y equal to x. So I'm going to write x instead of y in the left-hand side, write x. Replace y by x and x by y. So it is x multiplied or equal to 2 multiplied by y minus 4. On what we did, we replace y by x and x by y. Third step, step number 3. Solve for y. We need to solve for y. Now I have this equation x equal to 2y minus 4. Move this minus 4 to the other side or add plus 4 to both sides. I will have, this is, move it to the other side. I will have x plus 4 equal to y. Now this one will give me y, if we divide by 2, y equal x plus 4 divided by 2. Now this is the inverse of the given function. So we can say that f inverse of x equal to x plus 4 divided by 2. So this is how to find the inverse of a given function. So again, you have 3 steps. Step number 1, let f of x equal to y, then interchange between x and y. Third step, solve for y, means leave y in one side and everything will be in the other side. So it is y equal. We can say we are writing y as a function of x and some constant. So this is the inverse for the given function. Let's have another example. Number 2. F of x equal to 2x divided by x minus 1, where x is not equal to 1. So if x equal to 1, then the denominator will be 0 and it is undefined to divide by 0. So let's apply the 3 steps. Step number 1, let f of x equal to y. So it will be y equal to 2x divided by x minus 1. Second step, interchange between x and y. Let y equal to x and x equal to y. So this will be x equal to 2y divided by y minus 1. Second step, we interchange between x and y. Third step, let's solve for y. I want to solve for y. So by the cross multiplication, 2y times 1 and x by y minus 1. I will have 2y equal to x multiplied by y minus 1. I want to solve for y. So this is 2y equal to x, y minus x. Just multiply x times y and x times minus 1. Now move this term to the left-hand side. I will have 2y minus xy equal to minus x. Take y as a common factor. It will be 2 minus x equal to minus x. And now divided by the 2 minus x, I will have y equal to minus x divided by 2 minus x. So the inverse function f minus 1 multiplied by minus 1, or the inverse function, is equal to minus x divided by 2 minus x, where x is not equal to 2. But if x is equal to 2, this function will be undefined. So this is how to find the inverse function. Again, we have 3 steps. Step number 1, let f of x equal to y. Step number 2, interchange between x and y. Third step, solve for y. The result will be the inverse function. Take another example. Number 3. F of x equal to 4 minus x, where the domain x is less than or equal to 4. Again, step number 1, replace f of x by y. So this will be y equal to square root of 4 minus x. Step number 2, interchange between x and y. I would have x equal to 4 minus y. Now I need to solve for y. I have x equal to square root of 4 minus y. To solve for y, I have to square both sides. I will have x squared equal to 4 minus y. The x squared equal to 4 minus y. Now to solve for y, this will be I can shift this to the other side and keep x to the left-hand side. I will have y equal to 4 minus x squared. That is 4 minus x squared. This to the other side. Now y equal to 4 minus x squared. But we have one problem in this function now. Y equal to 4 minus x squared. The graph for this function, this is 4, and this is 4 minus x squared. It is down. By the horizontal line test, we can see there is two intersecting points. If I graph any horizontal line, you can see it means this is not one-to-one function. It is not a one-to-one function. It is a function y equal to 4 minus x squared, and to make it one-to-one so that the reverse will be okay, we have to give some restriction for the domain for x. So for this one, we will say that x, with one condition, x greater than or equal to 0. We must satisfy this condition. X must be greater than or equal to 0. It is this side. So the inverse function in this case of x equal to 4 minus x squared, with one condition that x must be greater than or equal to 0. If we go back to the original function, f of x equal to square root of 4 minus x, this one. If x equal to 4, if we replace x by 4, we will have square root of 4 minus 4, which is equal to 0. So y equal to 0. And we said before that the domain of the function equal to the range of the inverse. And the range of the function will be the domain of the inverse. Since the range of the function R, the range is equal to y greater than or equal to 0. The range is equal, y is greater than or equal to 0 because x starts from 4, so 4 minus 4 is equal to 0, and all the values of y must be 0 or greater than 0. So now if we reverse the domain and the range, we will see that the domain for the inverse function will be x greater than 0. It is the same one of these. It's the same range of the original function. And that's why we have to put this condition. The inverse function is equal to 4 minus x squared, where x is greater than or equal to 0. So I have one more example. Number 4. About that we have this function f of x equal to x squared minus 6x plus 1, where x is greater than or equal to 3. So let's apply the 3 steps. Step number 1, replace f of x by y. Y equal to x squared minus 6x plus 1. Now interchange between x and y. I will have x equal to y squared minus 6y plus 1. Now I want to solve for y. But this is a quadratic equation. And to solve a quadratic equation, or to solve for y, I'm going to use completing the square with respect to y. So I'm going to use completing the square by I want to complete the square for the left or for the right hand side. I have x equal to y squared minus 6y plus 1. Now to complete the square, we have to add. So we need to add the coefficient of y, 6 or minus 6 divided by 2, and square it. So I have to add 9 to the left-hand side and right-hand side. So in this case, I will have x plus 9, the left-hand side, equal to y squared minus 6y plus 9 plus 1, this one. So I have x plus 9 equal to y squared minus 6y plus 9. Now y squared minus 6y plus 9, this part is perfect square. Perfect square, it means we can write it as bracket 2 power 2 and keep plus 1 outside. So I'm going to shift it to the left-hand side later on. Now y squared minus 6y plus 9 using special factoring or perfect square. This can be written, take the square root of the first one will give me y. Square root of 9 is equal to 3 and the middle sign is negative. So it is y minus 3 to power 2 plus 1. Move it to the other side. I will have x plus 9 minus 1 equal to y minus 3 square, or x plus 8 equal to y minus 3 square. Now I'm going to take the square root. The both sides. I will have square root x plus 8 equals square root of y minus 3 square. Left hand side is equal to square root of x plus 8 equal to. Now the square root of y minus 3 all square is plus or minus. It is plus or minus y minus 3. Square root of y minus 3 square will be plus or minus y minus 3. Because we don't know what is y, if y is positive or negative, we take the positive or negative. Now I have to choose one of them. I have to choose either the positive sign or the negative sign. But this will depend on the domain in the question. We have x is greater than or equal to 3. Don't forget that we interchange between x and y. If we interchange, I will say in this case y, it is like in the second step in this one, it is y greater than or equal to 3. Now y greater than or equal to 3. It is this step. Y greater than or equal to 3. It means if we move this to the other side, it will be y minus 3 greater than or equal to 0. It means it is positive. So we are choosing the positive sign. Because y minus 3 is greater than or equal to 0. So we are choosing the positive sign. So square root of x plus 8 equal to y minus 3, or move it to the other side, I will have square root of x plus 8 plus 3 is equal to y. It means the inverse for this function is equal to square root of x plus 8 plus 3, with one condition that x must be greater than or equal to minus 8. It is the domain of under the square root. So this is the inverse for the given function. So if you are given a quadratic function x squared minus something, all what we need is just to do it by completing the square, take the square root, and solve for y to find the inverse function. So this is the idea of finding the inverse of some quadratic function.